Today we're going to be talking about pH, temperature, turbidity, contamination plumes. So you should have this sheet in front of you. But let's just think back to some things. Prior to this, you learned some things about water pollution, and you learned some things about testing the water quality of things. What were some of the things or some of the ways, some of the things we had to look to test water quality? What were some of the things we had to do? Aaron, give me something. We did have to check turbidity. Let's stop right there for a moment then. What is turbidity? What is that? What are we doing, Bryson? The clearness of the water. So how cloudy or how clear the water is, which means how much stuff is in the water. Doesn't always have to be dirt, but just how much stuff is in the water. All right? Let me go back one other time. Why are we checking the quality of the water? Duran. Safe to use? Why else?
Like if it's, well, I was about to see if it's safe enough to put back into the environment.
Okay, maybe to see if it's safe enough to put back into the environment.
To protect aquatic life.
Good answer. To protect aquatic life. See if it's even safe for aquatic life to live there. We may study and see why. Maybe we might see why is aquatic life dying, or why is aquatic life flourishing in this area. All right, so we said turbidity was one. We have 5. What's another one? Chris?
pH levels.
pH levels. What does that mean? What are we checking for pH levels, Drew?
Potential hydrogen.
Potential hydrogen, but what are we checking? And try not to look at your notes for this, because we need to be studying for this unit test that we have.
How acid, or to see if a substance is acid or base.
See how much acid or how much base or how acidic or how basic or alkaline a substance is. So we're looking for the presence of acid or the presence of base. Speaking of that, I do want you to look at your notes for 1 second. And on your notes, underneath where you have pH, and we put 0 to 6 is acidic, meaning presence of an acid. Next to that, I want you to write anything below 7. Below 7 would be the presence of an acid. For basic or presence of a base or increased alkalinity, above 7. All right? Fix your notes. Let's go ahead and get started. So you have this sheet in front of you. Now for this sheet, because we don't have the equipment to check for everything, so we talked about some of the things that we needed to look for. One of the things being, you said turbidity, you said pH, that's 2. Give me something else. DO, which is dissolved oxygen. So we're checking for the oxygen levels. Why are we checking for the oxygen levels in water?
See if it's good for fish to breathe in.
Yes, because fish do use oxygen. They don't breathe because they don't have lungs, but they do have gills, but they do need the oxygen. We don't have the equipment to check for DO in here in this environment, so that's one thing that we're not going to check for. But if were in an environment where we could check for that, that would be something that we have to check for as well. Give me a 4th thing, Patrick. Nitrate levels. What is that? Try not to look at your notes. No, not the, well, kind of. You're kind of at it. But help me out, a little bit more. Nitrates, what are we looking for? What is that? What are we checking for? The amount of what in water? Nitrogen and oxygen. Where do those things come from? Where do those things come from? Plants and animals. And the plants and animals would be where? Huh? No, where would we get the nitrogen from the plants and animals? Where would that come from?
Plants.
Fertilizers. You could get it from the plants. Poop that infiltrates. Yes. So we get it from farmlands, industrialization, things of that nature, sewage, all of that stuff. It could go in there. Too much of it is not good. Just the right amount of it is okay. If we get too much coming from all these areas, what was that big word?
Not quite sure.
No. Eutrophication. If we get too much. Okay, so we said turbidity, we said DO, we said pH, we said nitrate levels, and now we got a fifth one.
Change the temperature.
Temperature. What should the temperature be? Aaliyah.
25 Celsius to
Degrees
Celsius.
Celsius. You can't just say Celsius.
She was on her nose.
So she said 25 degrees Celsius to
45.
Okay, 45.
Degrees.
On your notes, I want you to change it to 20 because 20 is actually okay. So 20 degrees Celsius to 45 degrees Celsius, that would be fine. All right? So now what we do as marine biologists and when we're checking the quality of the water, we have to have a list and we have to check off all these things to make sure that the water is safe. The water has to meet every qualification. It can't just meet some. Now, you could meet some of them and you say maybe the water may be healthy. But if it fails majority of them, then it's no. You have to check off a list like did it pass this, like a rubric. Did it pass this? Did it pass that? So let's take a look at our paper that we have here. And it says, what tools do we use to check the pH of a substance? What tools do we use? Chris.
I forgot what it was called, but it was, I think it was this thing, it was like a little circle thingy.
That's not the pH. Not the pH. You got something, but not the pH. Drika.
It was like a strip of paper, a pH strip.
Yep, it's this. This is called pH paper. Make sure your P is lower and your H is uppercase or capitalization. It's another name for pH paper. What is it, Duran?
What it does is like.
No. You didn't listen to my question. What's the other name for pH paper?
Oh, it's not an S.
Nope. Nope. pH paper is also called litmus paper.
Oh yeah, litmus.
How you spell it?
pH paper or litmus paper? Litmus. Litmus. Now what happens? Someone explain to me, how does this pH paper work? Chris?
You dip it in like water.
A substance or water,
Substance, and then it changes color and tells you.
Does the paper change color and say, hey, I'm a so-and-so?
No, it changes color and then you have to get this other piece of paper and
You have to measure it to the chart, and the charts aren't always the same. You take the little strip, you put it up against the chart, and whatever color it ends up with, then you know that's the number, and then you already have your coding knowing that certain numbers are acids, certain numbers are bases. In class today, I don't have pH paper with me, but I will have it in class on Monday. All right. Take a pencil. All right. So when checking for pH of a substance, we are checking for the presence of what? The presence of acid or base. I didn't ask you what pH stands for. You have to listen to the questions, right? Presence of acid or
Base.
what are you saying,
That's one of the things I was talking
honey? But I'm asking you this question, and I just said a second ago, you gotta pay attention to the question I'm asking. But if I ask that we're checking for the presence of acid or base with pH, why would you yell out oxygen levels? That was the next thing, but I never said that. I never asked that question. All right. Now, what tools do we use to check temperature? Eddie? A thermometer. Everyone should have had their hand up for that. What does thermal mean? Thermal means heat. What is meter? Measure. So a thermometer is actually measuring the amount of heat. It's not measuring how cold something is. It's measuring the amount of heat. Okay? And if it is something and something is cold, that means there's an absence of heat. All right. All right. In science, we measure temperature in degrees Celsius. Someone yelled meters, and that is the dumbest answer I could have heard. It's okay. We can still put that there. What is turbidity again? Madison? Okay. So it's measure. We're going to put the cloudiness or the amount of stuff. Okay? How do we check turbidity? Take a moment. Don't raise your hand. I want you to take a moment and write down your answer on how you check turbidity. Don't wait for me because I'm not going to be writing anything. That's what you should be thinking about. That's exactly what you should be thinking about. About a minute and a half to write down how you check for turbidity. Alrighty. How do we check for turbidity? Jamil, speak loud. Okay. Okay. So what he said is we take a sample of it, we put a strip on the wall, and we put it against there and see if we can see it. Okay? That's one way. This here. What was another way that we can measure turbidity? Bryson. Okay, very good. So, in measuring turbidity, you can do it two ways. One way, like you said, have a strip of red or a dark color that you could see through, and you would measure it up against. So you would say, okay, if you can see right through it, then we would say it's clear. Maybe you can see a little bit, then it's low. These would be considered okay. If it's medium, it might still be okay, but it becomes high and even really high, then we have a serious problem.
Which one do we use? Clear and low?
I just said these two would be okay. Now, with that being said, would this be low turbidity or high turbidity? Low. And this would be really high turbidity. The other way was with the Secchi disc. A Secchi disc will have contrasting colors. For instance, this is black and white. You would put it on a long string and you would lower it into the ocean or the body of water. And you would count how many knots would pass sea level. If it's a lot of knots, then it's high turbidity or low turbidity. Low turbidity, meaning you can see it very, very far down. If it's not a lot of knots, then it would be high turbidity. All right? So you should have your answer on your paper for that. All righty, moving on. Now we're going to have 7 substances that we are going to actually look at. So we're going to list on our paper 7 things. So 1, 2, 3, 4, 5, 6, and 7. Everyone with me? Okay. And we're going to check the pH level, but because I don't have the litmus paper here, I have to give you the pH. But in the future, you will be able to dip it in the substance and check it against the chart and see what the pH level would be. All right, so let's start off with our first substance. Our first substance looks like this. Our pH level for this substance is a 3. Would that be acid, base, or neutral?
Acid.
Acid. All right? For the temperature, I'm using a thermometer. It's hard to see on there, so I will tell you. The temperature is 20 degrees Celsius. And then we're going to check the turbidity. Notice I have a red strip right here. I'm going to check it this way by laying it against the red strip. Would it be clear, low, medium, high, or really high?
Clear.
Clear. All right, remember we have 5 checks that we have to do. One is DO, nitrates, we don't have access to those. So pH level is 1. Does it pass the pH test?
Yeah.
Because our question is this body of, if this were a body of water, would it be healthy? Does it pass the pH test?
No.
No, because it should be a pH of what?
6.5.
6.5 to 8.5 for it to be okay or be healthy. Does that pass the temperature test?
Yes.
Yes, because I told you to change it to 20 degrees. Does it pass the turbidity?
Yes.
Yes. But would it be considered healthy?
No.
No. Why? It doesn't pass the pH test. This substance is actually vinegar.
Yeah, I knew it.
Yes.
All right. For our second substance, that's this here. Our second substance has a pH of 5.5. Acid, base, or neutral? Acid. The temperature? It's 21 degrees Celsius. Okay, thank you.
Clear.
It will be clear. Does it pass the pH? Well, let me go backwards. Does it pass turbidity?
Yes.
So far we could probably say, yeah, it's healthy. Does it pass temperature?
Yes.
Does it pass pH?
No.
And this is rubbing alcohol. Rubbing alcohol. All right, for our third substance, this has a pH of 6.7. Its temperature, first of all, is it acid, base, or neutral?
Neutral.
What's neutral?
7.
7.
7 is neutral.
Read your notes, Duran. So this is a acid. Anything below a 7 is a acid. The temperature is 22 degrees Celsius. All right, putting it up to the test for turbidity, really high. Did it pass the pH level?
Yes.
Yes, because it can be between 6.5 and 8.5. Did it pass the temperature?
Yes.
Did it pass turbidity?
No.
No, therefore it would be
Not healthy.
no, and this is milk. All right, number 4. This is number 4. This has a pH of 6.5, which means it would be,
Acid.
Patrick, I need you to look. There's no such thing as an acid base. You have to look at your numbers. If it's below 7, it is a acid. If it's above 7, Patrick, it's a base. You can't be in between. No, it's acid. The temperature of this substance (20°C). The turbidity, clear. Did it pass the pH?
Yes.
Yes. Did it pass temperature?
Yes.
Did it pass turbidity? Pass temperature. Did it pass turbidity?
Yes.
Is it healthy?
Yes.
Because it's water.
Yeah. That's all right.
Number 5. Number 5's pH is 12. What is it? Base. If you said it's urine, then you're not looking at your notes. Because if it were urine, the pH would be what? 6 to 6.5. The temperature is 20°C. The turbidity, low. Did it pass the pH test?
No.
Did it pass temperature?
Yes.
Did it pass turbidity?
Yes.
Is it healthy?
No.
No. Good, because it is cleaning solution. All right, our 6th one is here. The pH level is 9. What would that be? Base. The temperature is also 20°C. Our turbidity, it would definitely be high. It could be high to really high. Would it be healthy?
No.
Did it pass the pH?
No.
Did it pass temp?
Yes.
Did it pass turbidity?
No.
No. So it's not healthy, and this is baking soda solution. All right? Our last solution, I'm going to start with the temperature. First, you write it down as I tell you. Our temperature is (63°C). This is our next substance. I didn't give you that yet. 60°C. Our turbidity would be clear. Our pH is 7. So this would be neutral. Did it pass the pH test?
Yes.
Perfectly. Perfect pass. Did it pass the turbidity?
No.
Turbidity.
Yes.
Perfect. Did it pass temp?
No.
No. So is it healthy?
No.
No. But it is water.
So warm water.
How do you think, doesn't matter what it is, it's water. If this were a body of water, what could have possibly happened to raise this temperature? Maybe the sun, but not that hot. What was that called? What was that called? From your notes, Eddie. What was that called if we raised it, the temperature went up? Thermal pollution. Other stuff could have been added to the water that does not change the turbidity. It may or may not change the pH. If stuff was added to the water, the pH could have probably been 7.5, 8, something like that. But it still would be okay, except the temperature would raise, which means that it raised the temperature of the water, providing thermal pollution. All right, any questions on that? Okay, then go ahead and turn your papers over to the back. And when you do, you end up with a sheet that looks like this. All right, questions? Okay. What is a contamination plume, Jenny? It could be, but I want a little bit more information about a contamination plume. Okay, contamination of underground, not due to groundwater. What does it come from? Like where? Like how did those toxins get there? Industries and factories. So it's contamination underground. It's actually contamination from ground source. So it's contamination from ground source. I'm thinking you guys can see the screen. I apologize. That flows through what? Aquifers. Also, and what's in our aquifers? Groundwater. And spreads. So what we're going to do is we're going to demonstrate point source pollution and non-point source pollution. And we know that point source pollution means what? You know where it comes from. Non-point source pollution is what? It comes from many sources. So, remember, this is our land. Remember when it rains, what happens?
Water seeps into the ground.
What that seeping into the ground is called what? Infiltration. Then it does what? Percolates. So, we're going to let it rain and clear it out. So notice how our rain is spreading, it's infiltrating and percolating. Mm-hmm. So we have an area where it's going to be point source pollution, and we have an area where it's going to be non-point source pollution, but both areas have been rained on, right? And that's how we fill up our aquifers and our groundwater. You'll be able to see your phone. This is just the water. Alrighty. You can't sit there because you know can't see. You'll be able to see just fine. I'm not doing anything. From there, once we do that, now we're going to create the pollution. So, point source pollution again means that we can identify the source. We can identify where it comes from, so it comes from one source. So we're going to create a source of pollution, and we're going to pollute that area. All right? And then it rains some more in the recharge zone. Okay? And we're going to let that sit for a moment because it's going to take some time for it to actually infiltrate and percolate, because the pollution also infiltrates and percolates, correct? And remember, this could be a landfill, it could be a factory, it could also come from farmland and things of that nature. So we're going to let that sit there for a moment. We're not going to do anything. But in our next location, nothing's happening today. Our next location, we have non-point source, meaning it comes from many sources. So we have an area here, maybe we have an area there, and we have an area there. Let's say we even have an area over there. And we need to pollute those areas. It's not that, it's pollution. And then rain still happens. And we're going to let that sit and take some time. And in a moment, we're going to look at the groundwater of these two areas. Meaning that we have to let it infiltrate, then percolate. And we're going to take a look. So, let's take a look at our point source. And we're going to actually draw this. So notice we have it starting at a source, right? You want to draw it. And what happens? Over time, it spread it out, for sure. And then we even have a little bit over here. Now let's say we had a well over here. Let's say this was a well. There's no pollution there right now. Let me put that in a different color. So again, let's say there was a well here. Would we be concerned about that well? Yeah, because over time it could become polluted unless we clean this area up. What if we had a well here? Those people are in danger big time. They may already be contaminated. And notice how our pollution is still continuing to spread down here. There's some right there. So we got some spreading down there. All right? So now, let's take a look at our non-point source pollution, which means several areas. So we have a couple sources, and they've all spread it out. And if we had a well here, or here, or even over here, we're concerned, definitely, right? Because we even have a little bit of pollution that's got way over here. All right, so let's take a look at our questions. We're going to summarize the similarities in how contamination from point source and non-point source pollution moves through an aquifer. The similarities of how it moves through an aquifer. What's similar about how both types of pollution moves through an aquifer, Rajala? They both spread. They definitely both spread. Both spread through what? Spread through what? Through the aquifer. And the aquifer is also where our what's located? Groundwater. What are the differences in how the contamination from each source moves or flows through the aquifer? What's the difference? Janie,
That non-point source pollution
I'm going to abbreviate NPS, non-point source.
spreads faster than
It may not necessarily spread faster, because you don't want to think faster means more locations, but it means it what?
More.
It spreads
More.
more. Affecting what? More areas. And that it does affect wells, but affecting more area. In a shorter or a longer amount of time?
Shorter.
In a shorter amount of time. That's where we're getting that in, Jenny. Okay?
I'm not saying I don't know my better, but source pollution. Can't you like when you if you know the source is, can't you kind of like
It's
stop
easier
it?
to contain it because you can stop it, but once the damage is done, now you got to clean that damage up. Got it? All right. Then our last question. Is it on my desk? It's fine. Our last question. Where could contamination plumes come from? What do you mean, people? You got to be a little bit more specific. Sewers. It's fine. Bryson? Toxic waste. We can say toxic landfills. Where else could it come from? Rogerland. Like
People affecting and stuff.
factories and industrial businesses. You want to go with those types of things. So landfills, factories and industrial areas. How do contamination plumes affect groundwater? How do they affect groundwater? These are the only 3 people in class today? Ray. Nope. I want to know how it affects groundwater. How does it actually get into that groundwater? What does it do? What happens from there? Elia.
From inside the groundwater, it spreads
So it spreads good with groundwater. Affecting, how do we get our drinking water from what?
Wells.
Good job, Patrick. Affecting wells. And then eventually
What?
affecting our drinking water, farm water, etc. I'm going to put etc. because you can say your cleaning water, your cooking water, your bathing water, all of that stuff. Any questions about what we just covered today? Okay, and that concludes the lesson.